All right, welcome back. Today, we're going to jump into a really critical moment in modern database history, the release of YugabyteDB 2.0. Picture this. It's 2020. The entire world is stampeding towards the cloud, and inside a ton of companies, there's this major tug-of-war going on.
So let's talk about this dilemma, because it was a big one. On one side, you had this desperate need for cloud-native scale. Businesses needed their databases to handle these huge, spiky workloads, all over the planet without just tipping over. But on the other side, you had decades of money, tools, and just pure human know-how, all wrapped up in the familiar world of Postgres. For the longest time, it really felt like you had to pick a side.
And then, YugabyteDB 2.x shows up with this game-changing question. This wasn't about finding some clunky compromise, nope. This was about bringing two worlds together. It was selling this new reality where you absolutely did not have to ditch all the powerful stuff you love about SQL just to get the resilience and scale you need from a modern, cloud-native architecture.
So how'd they pull it off? Well, the key was an API called YSQL. And let's be super clear here. This was not just some thin compatibility layer slapped on top of something else. It was a fundamental rethinking of PostgreSQL's front end, built from the ground up to talk to a massively powerful distributed backend.
And when they said PostgreSQL compatible, they meant it. They were committed to full coverage. We're talking about the features developers live and breathe every day. Those complex joins, the triggers that fire off business logic, stored procedures, all of it. And maybe most importantly, it kept full ACID transactional guarantees. That means your data is always consistent, always reliable, even if it's spread across 3 different continents. Developers didn't have to throw out their playbook and start over.
Look, being able to speak the same language as PostgreSQL, that was huge. But it was only half the equation. The real innovation, the seriously heavy lifting, was happening deep down in the database core, making all those features we take for granted actually work in a distributed world.
Because here's the thing. To be a true distributed SQL database, you can't just put a pretty SQL face on a simple key-value store. It just doesn't work. You have to go all the way down and re-engineer the absolute fundamentals, the building blocks of the database itself, for this new distributed reality.
And this is where things get really cool. I mean, just think about it for a second. How do you even build an index on a table when its rows are scattered all over the globe? How do you enforce a foreign key relationship when the parent and child rows might live on totally different servers? And how do you make a schema change, like adding a new column, a single, safe, atomic operation across your entire cluster? These are incredibly hard problems, and YugabyteDB 2.x actually solved them.
All that hard work on the core foundation immediately paid off with features for real-world global apps. You could now spin up read replicas in different regions to give your local users lightning-fast reads, and with geo-partitioning, you could literally pin data to specific countries or continents, which was a lifesaver for things like GDPR and other data residency rules.
Okay, so you've built this incredibly powerful distributed database. That's awesome, but how do people actually use it? How do they deploy it, manage it, and keep an eye on it? A huge focus for the 2x series was making sure the database wasn't an island, but a good citizen in that whole modern DevOps world. It was designed to just plug in. With native Kubernetes operators, you could automate all the tedious stuff like deployment, scaling, and recovery. It fed a fire hose of deep metrics into Prometheus, so you could build these amazing Grafana dashboards and see exactly what was going on. And if you were juggling complex hybrid or multi-cloud setups, the Yugabyte platform gave you that one central place to manage everything.
So, what's the end result of all this tech? Well, adoption just exploded. All of a sudden, these really demanding industries saw a clear path forward. You had fintech companies building fraud detection systems and unkillable ledgers. Retailers were creating real-time inventory systems that wouldn't buckle during Black Friday. And SaaS companies could finally build truly global, multi-tenant apps right from the very start.
So if you had to boil the entire 2.x series down to just one single, powerful idea, what would it be? It's this. It took the concept of distributed SQL out of the lab and made it a practical reality for the rest of us. And this is the absolute key takeaway. For years, distributed SQL felt like something you'd read about in a white paper. Super powerful, sure, but way too complex and out of reach for most people. YugabyteDB 2.x changed the entire conversation. It made it something a real engineering team could download, plug into their CI/CD pipeline, and actually reliably run in production. It wasn't a dream anymore. It was deployable.
So in the end, that's the real legacy of the 2.x era. It successfully welded these two powerful worlds together.
On one side, developers got to keep the entire rich ecosystem and advanced features of Postgres that they already knew and loved. And on the other, the business got the mission-critical resilience, the massive scale, and the global reach that the modern world demands. It was, finally, the best of both worlds.
The 2.x series laid down this incredible foundation. It proved that a deployable, Postgres-compatible distributed SQL database wasn't just possible, it was practical. And that, of course, leads to a really interesting question. Once you've built that foundation, what comes next? What does it look like when a database like this truly grows up? Next time, we're going to dig into exactly that, as we check out the arrival of long-term support and what that signals for the future.